All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for this factoring, you're going to start by removing the 49 by multiplying it by 16. And so you're going to have x squared minus 56x, and then plus 784. Make sure that you replace the 49 in front of your x, and the two numbers that you're going to want to use are going to be negative 28. And so we're going to have 49x minus 28 again. Both of these will divide by 7. And so we're going to have 7x minus 4 and then 7x minus 4, which we can write as 7x minus 4 squared. And so this would be your answer for the factoring. For the math knowledge question, which of the following is not a factor of 1001? Easiest thing to do is just take 1001 and divide it by each of the numbers. 1001 does divide by 1. It does divide by 7 and by 11 and by 13. It does not divide by 17. If you divide it by 17, you get 58.8823, etc. And so it's not a factor because it doesn't evenly divide your number. So we are looking at lesson 80 today. We're finding surface areas and volumes of spheres. So hopefully you'll understand how to find the surface area and volume of spheres. So a sphere is a set of points in a space that are a fixed distance from a given point that's called the center of the sphere. It is a three-dimensional circle, basically. A circle, everything is a fixed point from the radius, and it's on one plane. All of your points are the same distance from your center. The radius is the length that they are all away from the center. Then a sphere is basically you take a circle and you turn it into a 3D figure. You spin it around and it makes your sphere. And so all of the points on the sphere are a fixed distance from the center of the sphere. And it's still called the radius. So a radius of a sphere is a segment whose endpoints are the center of the sphere and any point on the sphere. And so there's an example of a sphere, and the radius, you go from the center out to the edge. The surface area formula is 4 pi r squared. So our surface area formula for a sphere, 4 pi r squared. You do need to make sure to learn that one. The only thing that you need for a sphere is the radius, and that's the only thing that they can give you. Well, they could give you the diameter, which you just have to find the radius, but the only thing you need is the radius. So looking at an example, we want to find the surface area in terms of pi. So our surface area is 4 pi r squared, and our radius on this one, they tell us, is 8. And so 8 squared is 64, and then times 4 is going to be 256, and then pi, because it said in terms of pi, so we leave pi in our answer, and then it was inches, so inches squared. And so this would be your answer for that question. Okay, looking at the volume formula, it's 4/3 pi r cubed. So 4/3 pi r cubed. The surface area is 4 pi r squared. The one that has divide by 3 has the r cubed. You have to memorize those two formulas. If you get them mixed up, then you're not going to get the question correct. So you need to make sure that you learn those two formulas. So let's look at this one. We want to find the volume of the sphere. So our volume formula is 4/3 pi r cubed. And so we are going to plug in our radius, which they tell us is 16. And so if you plug that in, you're going to do 16 cubed, and then multiply by 4/3, and then multiply it by pi. And so if you do that, you should get 17,157.28, and then meters, and it's cubed because we have volume. Now, if you want, you could have left it as a number in terms of pi, but you would have ended up with 5,461 and 1/3, or 0.33. So I wouldn't recommend doing that. If you want, you can leave it like this, 16,384 over 3 pi. I'm fine with that. It didn't tell us to reduce it or write it in a specific way. So any of those three would be fine with me. But usually if I'm going to get a decimal, I'm going to either write it like this one here, or I'm just going to go ahead and multiply it by pi. I'm not going to usually do an improper fraction, a mixed number or a decimal and then pi. I'll do an improper fraction, or I'll just write my whole answer out in a decimal. But any of those three would technically be correct because they didn't specify how to write your answer. All right, so looking at spheres, we've now taken a sphere and we're going to cut it in half, and that's called a hemisphere. It's just half of a sphere. A great circle is a circle on a sphere that divides the sphere into two hemispheres. So whenever you have your sphere, I'm going to go back here. Do you see the dotted line that they've drawn around here? That would be your great circle, and if we cut it along the great circle, it's going to cut your sphere into two hemispheres. So if you think about the Earth, the equator is a great circle because it divides your sphere into two hemispheres, the northern hemisphere and the southern hemisphere. And so there's a picture of a hemisphere, and the great circle is this edge here. Right along there. That's your great circle. So we want to find the surface area and the volume of a hemisphere with an 18-foot diameter. Well, when we're looking at spheres and hemispheres, we don't care about the diameter. We want the radius. And so the radius is 9. Now, the surface area formula is 4 pi r squared. But if we're looking at a hemisphere, we're actually looking at half of that, which is 2 pi r squared. However, I'm going to go back to the picture of a hemisphere. That 2 pi r squared is going to find all of this part and the part that goes around back there, but it's not going to find the surface area of this face right here. That's a circle. This part right over here is a circle. And so this is the hemisphere, and then this is the part that was on the inside of the sphere. And it's a circle, so it's pi r squared. And so your surface area, 2 pi r squared plus pi r squared, is really going to be 3 pi r squared. That's the surface area formula for any hemisphere, because you have to take the outside of the sphere, and then when you cut it, you now have some more surface that you have to add for your surface area. And so our radius is 9, so we're going to say 3 pi 9 squared. So 9 squared is 81, and then times 3 is going to be 243 pi. And it's feet squared. And so that would be your answer there. You can leave it just like that. There's no need to multiply it by pi unless you just want to. Now for the volume. We have 4/3 pi r cubed, but we only want half of it because we're looking at a hemisphere. So half of 4/3 is 2/3. And so now we plug in our radius. And so we have 9 cubed. And then we multiply that by 2/3. And I get 486 pi, and it's feet cubed. And you are more than welcome to leave those in terms of pi. If you want to multiply them out, you can. It does not matter to me. If you want, you can write down this formula and this formula for hemispheres. If you want to memorize them, or if you want to just be familiar with them, you can. As you could see, though, it wasn't that difficult to figure out the volume and surface area formula for a hemisphere. Looking at the next example. A regulation soccer ball is about 70 centimeters in circumference. How many cubic centimeters of air does it take to inflate a ball of this size? Well, they tell us the circumference of our circle is 70. And we know that the circumference formula is 2 pi r. So 2 pi r equals 70. And so if we're going to solve for r, you're going to divide by 2 pi. Now, you've got to be careful when you plug this into the calculator. You're going to say 70 divided by, open parentheses, 2 pi. If you don't put these parentheses, you're going to get 70 divided by 2, which is 35, and then it's going to multiply it by pi, and you're going to get 35 pi, which is not at all going to be a correct number, because that would give you over 100, and that doesn't even make sense for a radius if your circumference is only 70. So you need to make sure that you do 70 divide by, open parentheses, and then the 2 pi. And so your radius is going to be 11.14. But then it asks how many cubic centimeters does it take to inflate it. So that's dealing with the volume. And so we're going to do our volume formula, 4/3 pi r cubed, and then we're going to plug in our r. And so we have 11.14. And we're going to cube that. And so then you're going to multiply it by 4/3 and then multiply it by pi. And so if you do that, you should get 5,792.19. And it didn't say where to round, so we're just going to go to 2 decimal places since it didn't specify. And then we're going to have centimeters cubed. So that would be your answer for that one. Looking at the lesson practice, let's see if you can do these two. Y'all pause the video and try them, and then unpause it, and I'll go over the correct answer. For your surface area, you're going to have 4 pi r squared. So we have 4 pi. Our diameter is 8, so our radius is 4. And so 4 squared is 16 times 4. It's going to be 64 pi. So if you multiply that, you should get 201.06, 201.06. And it said go to the hundredth, so that's why we went to 2 decimal places. And then it was meters, so meters squared. Looking at the next one, the volume formula is 4/3 pi r cubed. Our diameter they gave us is 22. The reason we know it's a diameter, they drew in the whole thing. So our radius is going to be 11. So we're going to do 11 cubed. And then multiply it by 4/3. And then multiply by pi. And you should get 5,575.28 and then inches cubed. And it said to the nearest hundredth, so that's why we went to 2 decimal places. Looking at the next 2 practice problems, y'all try these by yourself. So the surface area for a hemisphere, we're going to use our little formula that we found in the lesson, 3 pi r squared. So we're going to have 3 pi and then 16 squared. So 16 squared times 3 pi is going to be 2,412.74, and then we have feet squared. And then it also asks for the volume. Your volume formula is 2/3 pi r cubed. So we have 2/3 pi 16 cubed. So 16 cubed, and then times 2/3 times pi And so you should get 8,578.64 and then feet cubed because it's volume. Okay, looking at the last one, the snow globe's circumference is 20 centimeters. So we know that 2 pi r is our circumference formula. So we can divide by 2 pi. And so your radius is going to be, remember to put your parentheses around your 2 pi. Your radius is going to be 3.18 approximately. And so for the volume, because we're filling the globe up, we're going to have 4/3 pi r cubed. So our r we found to be 3.18. So if you cube that and then multiply it by 4/3 pi, you should get approximately 135.09. If you're not getting the same exact answer as me, that's because you are only plugging in 3.18. Whenever I plug this in to the calculator here, I didn't just plug in 3.18, I actually plugged in the whole number that my calculator gave me. So if your answer ended up slightly different than this one, slightly lower, that would be why. I plugged in 3.18 with all of the other decimal numbers behind it. Okay, so that would be why your answer may be slightly off. On the EOC, it's going to be acceptable. On the test, I would accept it if you were slightly off. But next year, I really am going to push for you to use the whole number in your calculator, and I'm going to start counting off if you don't. So I want you to go ahead and get in the habit this year of making sure to use the whole number that your calculator gives you. All right, so let's look at the challenge question. In order for an igloo to capture sufficient sunlight during the day to heat at night, it has to have a surface area of at least 115 feet squared. It wants us to tell whether the igloo shown has enough surface area to provide nighttime heat. And it says to ignore the doorway in our calculation. So we're going to assume that the doorway isn't there, that it's just ice. It tells us that the circumference is 27. So that means that 2 pi r is going to equal 27. And so if we solve for our radius, you're going to get approximately 4.3 if it's rounded. So our surface area, we're only looking at half of an igloo. It is a hemisphere, but it's not going to be the formula for a hemisphere because the bottom, that great circle, is not going to be able to capture sunlight because there's not going to be any sunlight hitting the bottom of the igloo. Think about your house. Sunlight doesn't hit the floor of your house unless you've got a window open or something, but it won't hit the floor of your igloo. So we only need to do half of 4 pi r squared, which is 2 pi r squared. And so we're going to do 2 pi and then 4.3 squared. Now remember, I'm not going to just put in 4.3. I'm going to use that whole decimal that my calculator gave me. So square that and then multiply it by 2 pi, and I get 116.02. And so it says, is that enough surface area? Well, is it greater than 115? It is, just barely. So does it have enough surface area to provide nighttime heat? It does. Okay, so your homework is problem set 80, 1 through 30. So you need to make sure you do that tonight so that we can go over any questions you have tomorrow.